What's going on, everybody? Welcome back to my YouTube channel. Now look at what we have here, which says find the value of x for which 7 to the power of cos square x plus 7 to the power of sine square x is equal to 8. Well, we have two trig ratios here, which is cos square x and sine square x, but I want to make it a single trig ratio. That means I want it to just be cos square x. I don't need any other type of trig ratio. I just need cos square x. And in order for me to achieve that, I'm going to be bringing an identity. Let's say recall that the identity for sine square x. So sine square x is equal to 1 minus cos squared x. The reason why I'm doing this is because I want to eliminate sine square x by substituting this. So let's go ahead and substitute this instead of sine square x. Let's go ahead and do that. So we have 7 to the power of cos square x plus 7. So instead of me to write sine square x, I'm going to be writing 1 minus cos squared x. So 1 minus cos squared x. You notice that I now have a single trig ratio of cos squared x equal to 8. Now I'm going to be applying the law of logarithm here, which says that when I have a, which is a base, to the power of x minus y, since this is minus, it shows that it is a division. So this can be written as a to the power of, this first power is x all over a, then the second power y. So the reason for this division is because of the minus we see here. So let's go ahead and apply this law of logarithm to this expression. So we have 7 to the power of cos square x plus, now we have 7 to the power of 1 because of this one here, all over, now 7 to the power of this second expression, which is cos squared x equal to 8. Now you notice that 7 to the power of cos squared x is appearing more than once, so we can substitute for that. So we can say let 7 to the power of cos squared x be equal to y. So this expression is now y plus, now 7 to the power 1 is 7 all over 7 to the power of cos square x. Remember we said we're taking that as y equal to 8. Now let's clear fraction by multiplying through by y. So when I multiply through by y, I'll have y squared plus 7 equal to 8y. So this happens when I multiply through by y. So let's go ahead and rearrange this since I'm seeing a quadratic equation here. So rearranging, I'm going to be having y squared. As 8y crosses to the left, it becomes minus 8y. Now I've already got plus 7 on the left equal to 0. So we have a good quadratic equation that we can factorize. Let's continue. So the factor of 7, which is positive 7, is 7 times 1 and 7 times 1, which is this can be negative, so that we have positive 7, right? Okay, and looking at this, I need negative 8. Whose addition will give me negative 8? You can notice that is second one. So this is a correct factor that we can use. So factorizing this quadratic equation, I'm going to be having y minus 7 times y minus 1. So this is a good factor equal to 0. Now applying the zero factor theorem, I have two cases, which is y minus 7 is equal to 0 or y minus 1 is equal to 0. So for the first case, y will be equal to 7 And for the second case, y will be equal to 1. Now, remember that we said 7 to the power of cos squared x be equal to y, right? Which is what we substituted. So let's go for the first case by saying case 1. So this is 7 to the power of cos squared x equal to y. What is y for our first case? Y for our first case is 7. So I'm going to be putting 7 there. You know, since this one has an exponent, this one also have an exponent of 1. Now, since the base are the same, we can equate the powers by saying cos squared x be equal to 1. That's equating the powers. Our next step will be for us to take the square root of both sides. So I'm going to be taking the square root of cos squared x. I'll also take the square root of the right hand side, but by putting plus or minus the square root of 1. Now notice that the square root can cancel off the square, leaving behind cos x to be equal to plus or minus the square root of 1 is 1. Now let's move ahead to the second case. So for our second case, let me write here case 2. So for case 2, following the same expression of 7 to the power of cos squared x be equal to y. For our second case, y is equal to 1. So we need an expression raised to a power to give 1. And what expression are we using? We're going to be making the base to be the same. So the base, if we want them to be the same, the base on the left is 7, so we can make the base on the right 7 as well. But when raised to power 0, we're going to be having 1. So we have 7 to the power of cos squared x to be equal to 7 to the power of 0. And remember, whatever value that we raise to a power of 0 gives 1. Now, since the bases are the same, we can equate the powers. So equating the powers, so power on the left is cos squared x equal to, the power on the right is 0. And taking the square root of both sides, we are also going to have cos x. The square root of 0 is always 0. So we have 0, cos x is equal to 0, and we have cos x to be equal to plus or minus 1. So therefore, the value of cos x is between -1 to 1. And if the value of cos x is between -1 and 1, that means the value of x is equal to k times pi over 2, where k is an integer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.